Okay, so today we're going to look at rules for differentiation. Now, this makes our calculus life so much easier. We're going to get through work a lot quicker, and it's really, really cool to use across the board. So, rules for differentiation, we've got two rules that we're going to look at on this page alone. And the first rule says that if we've got a function and it equals to a constant, remember, a constant is something that does not have a variable. So let's write that. Without a variable, you should know that. Without a variable. Do you see there's no variable? There is, can I just spell properly? Okay, there is no variable. There is no x in this function. Okay, so what is that answer then going to be if we're finding the derivative of it? Well, if we find the derivative of x, it's going to equal to 0. So write down the derivative with regards to x of the function of x. So if I want to write down the derivative of this, I can just write there f dash x is equal to 0. The function, the derivative of a constant is always going to equal to 0 because we're not using the variable. And again here, f dash x is equal to 0. And again this one, f dash x is equal to 0. So very easy. Anything that doesn't have an x or a variable with it and we're trying to find the derivative of that variable in this equation, you're going to end up just having a 0. Now, this takes me to a path where I can teach you about another way to write f dash x. So instead of writing the derivative of x like that, we can write it the derivative with respect to x. We can write it like that. So if I want to find out what that would be, the way that I rewrite this guy ends up just being d over dx, and we put a 4 next to it because we're trying to find the derivative of x with regards to this function, and we can write it as equal to 0. This is exactly the same. I don't like doing it with that color. Let's try and highlight it. This, guys, is exactly the same as that. The only difference is the way that we write it. Okay, so it's an easy way for us to just introduce this. Let's write it for this one. The derivative with respect to x of minus 3, and let's put that all in a bracket because that does make a difference, which is equal to 0 because we're looking at this whole function. We're not looking at those two items separately. And if we do it for this one, the derivative with respect to x of 0 is going to equal to 0. Easy enough, not too difficult. Whenever you have a constant, it automatically is a 0. Okay, now, rule 2 says that if I've been given a function and it equals to x to the power of some unknown number, we can then write the derivative of that function with respect to x by taking that exponent, bringing it in front of the x, multiplying it with that x, and taking 1 away from that exponent. So it's easier to do when we see it with numbers. So it says write down the derivative with regards to x of the function of x. So if this, I just want to make sure I'm on the right drawing tool, if fx is equal to x squared, then the derivative with respect to x, that ends up coming in front. So let's write that with a different color. We bring that down. That ends up being the 2 gets brought to the front and multiplied with the x. So we're still multiplying it with the x. And what do we end up doing? We take 1 away from that 2. Minus 1 from it. And 2 minus 1 ends up being 1. So we can write the derivative of this as 2x. Not too difficult, right? Let's go try it with that x to the power of 3. What do? We first take the exponent, we bring it to the front, and then we're going to minus 1 from that exponent. Okay, so let's write that out. If fx is equal to x cubed, then the derivative with regards to x is equal to, take that exponent, times it in the front, and we're going to minus 1 from it. 3x squared. That's my final answer. Quite easy, hey? Then it says, write down the derivative of x to the minus 4 with regards to x. Well, nothing has changed. We do the same thing. We end up writing fx is equal to x to the minus 4. What do? Let's draw it out. We take that, we multiply it in front, and then we minus 1 from that. So to write my derivative out, I'm going to write the derivative with regards to x of the function fx is equal to minus 4 multiplied in front here, ends up giving me minus 4, because there's an invisible 1 there, right? So minus 4 times 1 gives me minus 4, and we end up having x, and we're minusing 1 from minus 4, so it becomes minus 5. That's not too difficult at all. Okay, next we're going to go look at rules 3 and 4. Okay, rule 3. We're not doing rule 4 yet, we'll do that next. So it says that if f is differentiable, which means if f dash x exists, then the derivative of the constant, here's a constant, times the fx is equal to the constant times the derivative of fx. Oh, these definitions are terrible. But basically in English, it just means that if I have a constant, which is a number that is in front of my x, all I'm going to do when I solve for the derivative, I'm going to take my exponent like I normally did. I'm going to times it in front, and I'm going to minus 1 from it. And then my exponent times my constant is going to give me a value. And that value will be one single value at the end of the day. Okay, so let's try it out. It says, find the derivatives of the following functions for question 4, 5, 6, and 7. We did 1, 2, and 3 for rules 1 and 2, right? Okay, so here all we're going to do is we're going to take the exponent, times it with what's in front, and then minus 1 from it. That's the rule, right? So if I've got the function of fx, which is equal to 3x squared, and I want to find the derivative of that function, I take the 2 and I times it in front with the 3, and I times it with x, and I minus 1 from the top there. That's what it will look like. That's the process, right? And 2 times 3 ends up being 6, and x, 2 minus 1, ends up being 1. So I end up getting 6x. Easy enough. If you remember, we actually did this in our limit example in method 1 and method 2, if you go look back. Okay, now let's look at this one. We end up having minus 6x to the 6. So my function is equal to minus 6x to the power of 6. The derivative of this function is 6 times minus 6. So we're going to go 6 times minus 6, x 6 minus 1. 6 times minus 6 gives you minus 36, x to the power of 5. That ends up being my derivative. If we look at this one, we end up saying fx. Now, a lot of kids freak out when they see a fraction. Guys, separate the fraction from this variable. We know that we can rewrite this as minus 3 over 4, and that ends up having x to the minus 4. That minus 4 is only on this x. It's not on this whole item, okay? So When we see it like that, it becomes a lot easier and you guys stress less. So if we had to write this out, the derivative of x is equal to minus 4 times minus 3 over 4 x minus 4 minus 1. Remember, we're going to take away 1 from it. So to simplify this, I just want you to remember that minus 4 is the same as having minus 4 over 1. And when we get fractions, we always go tops times tops, bottoms times bottoms. But in this case, we end up having these two be the same. So we can actually cross simplify. 4 goes into itself once and can go into minus 4 minus 1 times. Now we've cross simplified it. We can times. Minus 1 times minus 3 ends up being 3, and minus 1 times 1 is still 1. We don't have to put it over 1. And we're left with x minus 4 minus 1 to the minus 5. That one was a little bit trickier, but it's just because it's a fraction. Separate that fraction out and you won't have a problem. Now let's look at this. We end up having x at the bottom. So I need to always make sure that when I'm doing derivatives, my x is never in the denominator. It's always in the numerator. And we know that if we're to move this up, all that's going to happen is we're going to change the sign on the 12. So we end up having 6x to the minus 12. And now I can go find my derivative of this function, which ends up taking this minus 12, timesing it in front. So we've got minus 12 times by the 6x, and I'm running out of space here, so I'm going to write it at the top, 12 minus 1. I don't know if you can see that. We end up having minus 12 times 6, so that's 60, 72, hey, minus 72, and 12 minus 1 gives you minus 13. We know that we can't leave it as a negative exponent, so we can always change it. We end up getting minus 72 over x to the 13 then. And that ends up being my final answer. Okay, guys, the examples in your textbook just gives you a different notation in which to use. It is your d over dx notation. Look at it, see how it's used. I'm not going to drill you on that now. I'd rather get you to understand this process first before we move on to changing your minds and seeing f dash x is equal to this guy. So we'll end up building on our notation in the next lesson. Okay, so don't stress so much. Cool, we're going to move on to rule 4. I hope you guys copied this down and I hope you understood it. Okay, welcome to rule 4 and rule 5. We call this rule 4 the sum rule and we call rule 5 the difference rule. And basically what it's saying is that if I have multiple functions added together or items with variables in it, I can just find the derivative of each one separately and then I can add or subtract depending on if I've got like terms. And on this side, we're going to do the addition part of it, and this side, we're going to do the subtraction part of it. So it's really, really simple. We want to find the derivative of fx, which is equal to x cubed plus 2x to the minus 3. So you find the derivative of each item individually. So f dash x is equal to, we change this guy to times in the front, take the 3 in the front, x minus 1 from it gives you a 2, and find the derivative of this. A minus 3 times a positive 2 gives you a minus 6, and minus 1 from this minus 3, you end up having minus 4. It's quite an easy way to do it. I don't know if I should show you the steps in between. Let me show you the steps in between, at least that way. You should know how to do this already. Let me erase it, it goes quicker. So just so that you can see the steps in between, we end up having what ends up changing. Let's go here. We end up having times the front, keep the x, and then minus the 1 from the 3 and you'll end up having the 2. So you see the changes there. And then we end up having a plus, where's my blue? We have a plus times what's in the front there. Hey, we keep the 2. We're going to have that 3 come to the front. 3 times here ends up being 3. Keep the x and minus 1 from the top. So minus 3 minus 1. That's what you end up doing. You can do that in your brain or you can do it on a paper, whichever helps you, but that ends up being 3x squared minus 6x minus 4. So back to the same example as before. Okay. If we try do it for the difference rule, find the derivative of each separately and then just minus them. So again, let's do this slowly. F dash x is equal to, take the 3 times it in front and minus 1 from it, right? So we end up having 3x squared. And here we end up taking, what is here? Guys, it's not empty, there's an invisible 1. Take that 1 times in front. So minus 2 times 1 still gives you minus 2. And minus 1 from that. So we end up having x1 minus 1, which ends up giving you 0, right? And what do we know about anything to the power of 0? Well, that whole item then becomes 1. So we end up having 3x squared minus 2, because that becomes a 1, right? Okay, are we happy with that? It's not really difficult.